Hello, folks. Welcome to another Rust stream. My name is Luciano, and today we have with me this guy.
Roberto, this guy with the beard. Look at it, it will disappear in the near
The
future.
smart guy.
Yeah.
And yeah, we want to continue our work on our Rust Twitch chat. And last time, what we did, and you will find all the recording on YouTube, by the way. So let me put that on screen. So if you're curious, you can check it out later. There you go. Basically, what we did last time is we are working towards this project where we are trying to build an integration with Twitch. So we run effectively a binary behind the scenes that can listen to the chat and can do things with the messages that are sent in the chat. Our final idea is to build some kind of a game where we are rendering something on the screen and people can interact from the chat playing the game that way. So maybe, I don't know, we drop questions and you can provide the answer, and whichever provides the correct answer the fastest gets points. We can do something like that. Or we can do like a quiz game where, I don't know, you have to answer questions about Rust or TypeScript or whatever. So at that point, the sky's the limit. Right now, we are only focused on building the basic functionality that allows us to interact with the Twitch chat. So I'm gonna switch back to Roberto's screen and we can quickly review where we are at from last time.
Yeah.
Cool. You should be seeing the screen. Let us know if it's big enough, cool enough, colorful enough, if Roberto has a very nice theme or not.
Nah, I don't have it. I'm the default. VS Code default, always. I stick with defaults. That's why I'm not ever using Vim or stuff like that, because you have to customize it. Nah, out of the box should already fit me.
You need to use Lunar Vim then, or whatever.
Oh, I saw that one. Yeah, I saw something about it. But well, next time I will show you Vim. Yeah, it would be no Vim. Sorry, it would be very funny for you to watch. I will not even be able to exit it. So what we did last time? Last time we created the client. Before, if you remember, we had everything in main and we were trying basically our parser. We created a client RS. We moved all the logic for the WebSocket connection in it. We started creating our client structure. The client will be initialized from the main RS, and we will tell which channel to use, name, which token is taken from the environment. Socket here is our web socket, is the WebSocket connection to Twitch. Then we have three vectors of callbacks, one for when there is a private message, one when there is a join, and one when there is an on part. That is when somebody is leaving the channel. Boilerplate. So new function that is initializing everything with a known socket. Then a connect function that will start to do the proper and shake with Twitch, that is using a IRC protocol, slightly modified, to communicate with us. So we send, look, we want to have membership and tags. We are passing you our password. We are called this way. We want to join this channel. And then we assign this some web stream client that is a very complicated type, if you ask me. So framed box of dynamic sync plus send sync and pin and whatever.
Yeah, there is even an ellipsis there because it keeps going.
Yeah, it keeps going. So, and some other stuff. So all of this beautiful stuff is set to our socket variable, and this being returning a result because it can error due to all the await that we have around, because the network communication is dropped in any moment. So we have to take in account that we are on network, so we need to be unreliable or reliable. We send back OK or an error when we try to connect. Then there are free utility functions to add stuff to our vector of callbacks, that they take a listener of type join or part listener, and there is another type that is the private message listener that are defined appear again as box dynamic function mutable of private message in a case, or user is the parameter in the other case. The send function is an utility function that is used to send something on top of the socket, basically. Here we get it as mutable, we unwrap it, and then we use it to send some string that is formatted here with the parameters that are provided us to the right channel. Then the main core of our client is this run function that we will call, and we will not await typically. Now in the main, I think we are awaiting because we are doing nothing else. But in theory, when we do the Bevy client or whatever other client, this will be a coroutine that will just start and will run in parallel in the background. There are ways of doing that. That is doing exactly the same. Is taking our stream out of the socket as mutable, and is getting new messages from it in a loop. If the message is a message based on the opcode, is doing text ping close. The first match out here, let's remember, is the match for the WebSocket with the WebSocket protocol. So it has the WebSocket ping. And then we have inside, if we get a text, we have to handle that message like a IRC message that again has its own ping, but is another ping, is not the previous ping. And then it can have join. At the moment, we only implement ping and join, but we should implement, and I don't know if we have time today, but we should implement part and private message. That part will call the callbacks in the vector for the part, and the private message will call all the callbacks for the private message callbacks vector. Okay, and we left last time here because if we look in main,
we had a problem.
We configured our. We take our Twitch token from the environment variables. We initialize our client with Logibot, and okay, and the token. We await for the connection. We add a listener for private messages, and then we just print on the console the private message. What we want to do is to answer to those messages, and here we started to have problem with borrowing with 3 R's because we are borrowing a lot.
Borrowing.
And, yeah, we are borrowing a lot, so 3 R's are better than 2. And yes, so we arrived here, if I remember correctly last time. Do you want to add something?
Yes, that if you uncomment this code, we can see what's the problem there. And then we'll need to fix this problem today somehow. And we have some ideas, but not really sure if those ideas are going to work. So the usual Rust problem, the bane of every Rust newcomer, which is basically, oh, you are doing more than one mutable borrow. What are you doing? Are you crazy? This is not memory safe. And indeed, it isn't. So what's happening here, like, is that we created a mute client, and we have this client there, but then we have multiple references to that mute client. I think if you click, can you hover again on the error? If you click on view problem, Alt F8, and then click full compiler diagnostic, I think we get a nicer view. Yeah, let's see if we can interpret this. But basically, it's saying that first immutable borrow occurs here in that closure. So the fact that we receive that private message thing. Then we have a first. So we are mixing borrows and mutable borrows. That's the problem. Either you have only one mutable borrow, or you can have as many as you want immutable borrows. But you cannot have one mutable borrow and one or more immutable borrows. So let's see. Was this Tommaso suggesting that in the chat? The closure is probably wrong type. So I think that's one thing. I think there are many issues there. The other issue is that we have a bunch of methods that all require
the socket.
They all require mutability in a way or another, because the socket is effectively a mutable thing. As you read and write into the socket, you are mutating it. and that makes sense, I suppose, by design. Our problem is that we want to create an abstraction that allows us to expose like an interface where you can say, okay, I want to receive messages in my callback, and then I also want to write messages anytime from inside my callbacks. And that already means having multiple mutable references, because from inside the callback and your client, you will have multiple references. So one
Now
idea.
I want to ask you something. Can I?
Yeah, go for it.
I was thinking of passing the client here as a second parameter. Then the client is defined here. To define the client, we need the private message type, and to define the private message type, we need the client. How do you solve this kind of stuff in Rust?
Not seeing the problem. Shouldn't be a problem.
Shouldn't be a problem. Is so smart to
Yeah,
do
it
that?
doesn't have to be in order, as far as I know.
Sorry, this is. I remember C complaining about this
It's
kind of
not.
stuff
Shouldn't
a
be like
lot.
C.
Shouldn't be stupid. So basically, no, because one of the idea I was trying to explain to talk about last time was, what if we pass back the client like this? I think we still have all the problem with borrowing immutability anyway, but I'm just curious to see if we can pass in this way. No, obviously it's not.
But
No.
you should pass it as a
Okay.
reference, as a mutable reference, right?
Yeah. Okay, no, this is just the wrong type. I have to declare because it's mutable up here. Okay.
So is it already
So
been passed as a mutable reference? I think you still need to do, yeah. Okay, you need to do that. And that probably is gonna ask us about lifetimes. Let's see. And now there, I think you also need to say mute ampersand
mute
mute self, I think,
again.
because otherwise you are not sure. Actually, I'm not sure.
No, we are borrowing multiple times as mutable, and yeah, it's the same problem as before. So expected mutable reference and reference at mutable. Okay, sorry, it was
Okay,
a
so
joke.
there are a couple of things that we can do. One was actually suggested by Thomas, and maybe it's easier to do it first. I'm gonna try to highlight it here in the screen. So there is another problem here. Let's ignore for a second the problem with the mutability, which is a big problem. But we also have another conceptual problem. If we look at our client struct definition, what we are saying is that there is a socket, but that socket is optional. So this client has, if you imagine it as a state machine, has technically two states: the connected state and the state where it's not connected. And we are expressing that with an option. Now, the problem is that certain things will make sense only when it is connected, and other things will make sense only when it's not connected. Like a state machine, you can have transitions, and certain transitions are allowed.
Connect makes sense only if you're not connected. Send message makes sense only if you are connected.
So there are many ways to solve this thing in Rust in a way that the type system is gonna make sure that you don't use invalid states. For instance, that you cannot call connect if you are already connected, something, or you stuff like that, basically. One quick way that we can do that is basically we can create two clients. One, we call it client, and the other one connected client, for example. And basically what we do is when we call connect consumes the client and gives us back a connected client.
Okay.
Now, and the connected client has the socket always, while the client doesn't have the socket at all, because it doesn't make sense to have a socket when it's not connected. Yeah, maybe it's more explicit if we call it unconnected client.
I prefer to. We have to change a bunch of code, but is the connected client containing the unconnected client, or is copying all the values?
We can move all the values at that point because we are effectively consuming the
No, but
unconnected class.
my question was more.
Oh yeah, I will copy paste them again. Just I
If
think it's a
we
little
want
bit
to
simpler.
do something like this,
I guess we
or
could.
not. Sorry, I wrote the wrong stuff. Copy paste is too much copy. Paste. Thank you. If we want to put the unconnected client inside the connected client this way, calling it config, because in reality it's just the configuration of the client, or if we want to copy and paste those 6 lines inside the other struct. What do you think?
Could work, yeah. It's just I'm not sure about
Or
the naming, but
this or that?
yeah, that one is
Yes.
less duplication.
Yeah, but this one, why there is all this stuff here?
Okay, then maybe I'm gonna suggest again to rename that to client again, and then we embed a client inside the connected client, like it's a
Okay.
wrapper.
And we call it client or configurations or how?
Even yeah, client, something like that.
So
Okay.
we go for this way with this approach.
Now in the implementation of the client, we don't need the token. Sorry, the socket.
Now our new is staying the same, except for that field. Our connect should at this point is already building the socket,
Thomas is
but is
saying
not
consume is the way. Yes.
so it's not mutable anymore.
It's just self, which is gonna consume, so it means you cannot call it again because it's
It
gonna
makes
take
sense,
ownership.
and is giving back at this point a result containing not an empty type, but a connected
Exactly.
client, if we are able to do so, or an error. So
Mm-hmm.
here, instead of doing this, we return a connected client of. Oh, by the way, I'm using Code's Whisper instead of
That's interesting.
your
Copilot.
Copilot. Yeah. Let's see what it suggests us.
Okay, let's send some data to AWS this time, not to Microsoft.
Well, we have to feed both beasts, otherwise they
Exactly.
die. Connect can also accept that the token is not okay to store the token in memory. Can be an idea.
Oh,
If
that
Tommaso
make that
obviously
we could remove it. You mean after the connection? Is that
we
what you're
cannot
suggesting?
pass it. We cannot. We can not pass it here, but having it here.
Good point. Yeah.
Sorry, I'm doing all the wrong shortcuts. Don't worry. That's the problem when you have
Imagine
when
if you
you.
were using Vim.
Yeah, with the Vim it will be a real circus show. So we can do something like this. We don't need this on self anymore. We have to remove this from here.
Nice. I like this refactor.
We pass it here, so we forget it about this. We return our connected client, and the run at this point must be implemented inside the.
Exactly. Now we can do another impl block and we move
Yeah,
the
we have to
same
cut it.
message. So everything that requires a socket needs to go in the other
So
implementation.
now we have to implement connected client.
I've seen other ways of
Okay.
doing this with generics, but it's pretty advanced. And I don't think it makes sense for only one state.
Okay, so now this channel is on top of self client. Here, what is complaining about? But well, now it's not optional anymore. No, it's
Oh
still
yeah,
optional, but it should not be
should
optional
not be
anymore.
optional. So we can also simplify
So
there a little bit
yeah,
more.
we have to change a bunch of code. Let's see. And here is not a sum, but is a
Hmm.
real is a real boy, is a real instance, not an optional. Okay, so now the stream is mutable. No, it's just
The stream.
self socket send. There is no need of self socket. There is no need of an additional variable.
I don't think so.
There's
Because
no
we,
need of
we
a
were doing an unwrap before, right?
Yeah, we were doing an unwrap. We were extracting the socket from the optional, but now
Hmm.
it's not optional anymore. I don't know if you want to still do this to have that in a variable, or if you just, or if we can just.
I think we will refactor that anyway in a second. So for now, let's simplify it as much as you can.
Here is complaining about the next. Why?
No method
No
name
method for the structure the current scope. It can only be used if the trait is in scope.
Did we forgot to add that trait to this file? Stream.xt.
I removed it. I removed a couple of imports before appear. I don't know if I removed the wrong one.
Yeah, I think we need to
Yes.
have this one, yes.
Sorry, my fault.
Meanwhile, I'm gonna rephrase what Tommaso suggested before. Basically, the idea is that we are not gonna store in the struct the token, and we try to have that token live as little as possible. So by having it only as an argument of the connect method, what happens internally is that it will exist in memory only when we are connecting, and then eventually it's going to be cleaned up when the connection completes or fails. So if someone is reading the memory of our process, the chances that they will find the token are much lower this way. With the previous implementation, the token would always be in memory as long as the client exists,
Yeah,
which
that
is
is
not ideal.
was not really needed. Okay, so now question here we still need the mutable.
Okay, here we still need the mutable.
It was a question.
I think as long as that it's fn mute, yes. But I'm still not 100% sure I understand the difference between mute and fn mute. Sorry, fn and fn mute.
Thomas is asking if running run should consume self. Uh,
I don't think so, because the problem is that while the loop is running, we still want to have a way to send messages in the
yeah,
socket.
yeah.
So I don't know if there is a way to do that otherwise.
Well, if we go back to main, something changed for main.
Yeah, I think we still haven't fixed the mutability problem, but now we need to change the way we initialize the client. So we have client doesn't have to be mutable anymore, and then when we call connect, we get a new client. Or you can even call it client again for what matters.
But we have to connect after we configure the callbacks.
True that.
We configure the callbacks on client. So you have to configure the client, configure all the callback that you want on top of the client, and you connect. At this point, here in the lambda, that is not called lambda in Rust, but okay,
Closure.
in the closure. Thank you. In the closure, we don't have the send client, and at this point we need to pass it as a parameter.
Yes, we can try that. I still think we will have that mutability problem, right?
Yeah, but if you don't want to pass it, how can you have the client before you connect? And you have to configure this before you connect, because after you call
Oh,
connect, you
yes, I see
consume
what you
the
mean.
client.
Yes. Yeah.
So here you are consuming client and getting a connected client. Here you need the connected client to be able to send messages. So the easiest way of having the connected client passed here is to pass it.
Mm-hmm. Yes. Now I'm wondering if this is maybe very JavaScripty. If it will make sense rather than passing the entire client to only pass a closure called send or something like that.
So here you just pass send of type
Of some type, which I don't know.
fun, something,
Yeah.
and then
Also,
here you do
it will be an async closure, which is it even
yes.
possible? I don't know.
Well, here we are trying to basically. So you have to do send here, and then you have to await it. But which kind of type is this one?
Yeah, it will be a closure that returns a promise. Sorry, a future. This is not JavaScript.
So what is the type of this guy? Attempted to take a value, the value of method send message on type, and it's not a field. So no, I don't think we can pass this function at this point, because it's complaining that it's not a field. So what we have to do?
Okay, for now let's
Something.
just pass a reference to the client, and then we see if we can change that.
Okay, okay. So now we pass a reference to self.
Yes, which will need to be a mutable reference, but for now let's just pass self
Okay, then
as
this type is a. We have to declare the listener. Then here as
oh yeah, that beautiful.
mutable connected client.
Mm-hmm. But as a reference. Yeah, perfect.
Okay. Then here it should complain in main that we are adding the wrong type of stuff, because this guy should only have one parameter. No, two
And
parameters.
it's yeah, if you remove the I wonder if for closures if you need to specify the type. I think it will understand it
No,
automatically.
he's understanding it.
Yeah.
Connected, mutable connected client. At this point, client dot send message was send MSG. What was? Give me a moment. Send MSG. But now this is complaining. No method. But this is
Did we implement it in the old client? Did we move it to the new
no method
implementation?
named found in the struct client. No, is
Or is maybe
white.
private?
Because sorry, because I call it this connected client, and I'm calling
Oh
the
yeah,
wrong
yeah. Fair.
value. Client is this variable outside.
Mm-hmm.
Okay, it's not complaining.
He's not complaining. Interesting.
I don't trust it. No, it's complaining here. Cannot borrow self as mutable more than once.
Okay. Cool. And this is where we were expecting to to have to do
So
something different.
here in the for loop, on top of the join, we are borrowing as mutable, and then we want to borrow as mutable again when we pass it to the listener, because to call send message, you have to call that on mutable. Yeah, oh, I don't understand exactly why here we are borrowing as mutable.
For listener in...
I mean, I wanted to loop on top of a vector that is never going to change again, because that vector is never going to change again. So why are we looping with a mutable on top of a frozen vector?
But it is the self client that is mutable, not the listener. Not
But
the
even the
join.
self client should not be mutable anymore. I mean, once we connect.
Okay. Try to remove the mute from there. Let's see what happens.
Try to remove the mute from there. Okay. So in this loop, we say that we loop on top of this.
So
now it's complaining.
We have a suggestion there. The borrow is kept by the stream. You can run consume self, split self into stream and config. Consume the stream, use client. I'm not sure I'm following. The borrow is kept by the stream. You can run consume self. Let me pop it up again. So if you do run, you consume self. Then you split self into stream and config. Consume the stream, use client. So basically you're saying that every time you call run, you get an instance of a stream and you lost the connected client. We have Oax Spirit in the chat. Hi, how are you? Asking, has anyone tried compiling Rust SDL2 code to WASM? I never use SDL2 with Rust and very little with WASM, so unfortunately not. Sorry. We might try in the future streams to compile Bevy to WASM, so maybe that could be interesting.
Well, okay, the first stuff up here can be solved with a dot iter. So instead of taking out the listener, we take out a reference to the listener. But then here is complaining that we can't borrow listeners mutable as it's behind a reference.
Okay,
and
now if you change that fn mute to just fn, does that disappear in the signature of the listener, of the callbacks?
You mean here?
Yes. Nope.
But well,
Yes.
the error changed. Cannot borrow self as mutable because it also borrowed as immutable.
So that's the other problem, that we are passing there an immutable reference, but we already have a mutable reference in the loop.
So immutable borrow occurs here on top of client. And then we want to also have, oh God. Yeah, we are coupling the client that contains the stuff that we have to loop on. We're coupling it with the stream itself. The stream needs to be mutable. The list, the vector and everything else is not important that is mutable. So, but we are keeping it mutable because they are inside the same struct. So Tommaso was suggesting to split them.
Yeah, to split them.
Yeah, that was.
But how do we split them in such a way
that we can keep a reference to them? Oh, instead of having the client, we keep a reference to the client. Instead of having the client inside the connected client, can we have a reference to the client inside the connected client? And at that point, that reference is an immutable reference. So here, can we have
so when you connect
reference?
I wonder
Okay,
if
now we need,
when we connect, can we just return the socket?
yeah, we call the methods, but then we need in the run method of the connected client, we still need to know the client configured
The
vectors.
socket, yeah.
So remember me where I have to put all the lifetimes. I never remember now, because if we do a reference, obviously is complaining about lifetimes.
Mm-hmm.
Because client should leave enough to let connected client use it, right?
Yes. I'm
Now,
still
here in
not
the struct.
convinced what's the final
No,
shape, though.
no, you're not convinced.
Can you repeat your suggestion? So you're basically saying that we want to split client and socket, but how? Okay, Thomas is saying you can wrap the socket in a dedicated structure that has the send message method.
That is not what we are already doing.
Yeah, I don't see why that is. We are just creating another level of nesting, but then doesn't the top level doesn't have to be mutable anyway, or not?
Yeah, here we needed to have to have access to that vector somehow.
And that is
But
something that we can do without mutability.
yes, because we don't have to mutate that anymore after
Exactly.
the connect. So our connect that is here is is putting self in this structure. But if we put an immutable reference to self, then that will be immutable and in theory should not complain anymore.
Yes, but then if you do that, you cannot do the run anymore. Or you
Oh
cannot
well,
even do the send, because the send.
no, the send is in the connected client, not on the client.
But then you will have at the same time a mutable reference and an immutable reference in just in two different places.
The
Right?
mutable reference to client, we don't need a mutable reference to client anymore after we connect.
Okay, we only need a mutable reference to the socket.
Yes, the only stuff mutable here is the socket. The client is not mutable. But I like we did now, if we want this mutable, also this one is becoming mutable. And this is giving us problems.
Mm-hmm.
My problem is let me think. Here we call run. Can we pass at this point to the run the list of callbacks instead of configuring them on the client?
We could, yeah.
Okay, let's try to do just an experiment. Okay, just let's try to do an experiment. Do you want to try?
Mm-hmm.
We refactor a little bit of code. So our config changes. It's just nickname and channel. Then we take this and here we create let this guy equal to a vector new, and then
Yeah, you can actually do vec exclamation mark rather
okay,
than
yes,
vec new. Vec
is the
exclamation
bug.
mark and then square brackets, and inside the square brackets you put the instance,
You put
the closure.
yeah, that starts here. Okay, I was looking for all the right parentheses. So now not able to infer. What is mismatch? Okay.
You're missing a parenthesis there, yeah.
Yeah, sorry. And on with an O and not with a. So now,
Zero n.
and now we pass this here. Okay. Now we have to declare that our is taking a vector of this. Let's see if we need to make this type public and use it in main. I'm not sure about it. So mutable reference to self and on priv msg of type vector of that. Now here on well the on join we were using the on join or the private msg. Anyway,
Doesn't
let's
matter.
change it. Let's change it. What is taking the private msg? Taking a private msg message. Now we loop on top of our variable that we passed in run. I don't know if we have to iter or not. Let's try to not iter for now. See what it thinks. There is no an our listener.
And you need to pass, rather than a user, a private message, right?
Yes, but we wrap it, so we need to pass the inside one or the outside one. Know that we are.
Yeah, depends how we define the signature. I think the inside one.
Private message and
So that's
outside.
correct.
Okay, we have the one inside the enumerate. Okay. Here, use of moved value. So we need to do inside of this loop. Move occurs here.
So you can do an ampersand on private message. So we take a reference there in line 105. That's what Thomas is suggesting.
Here or here?
No, I think there in line 105.
Okay. Okay, now what is there is a complaint? Nowhere? No.
There, connected client.
Okay, type annotation needed. Yeah, because here is just what is the type of this? Oh God, again is a reference mutable connected client. Reference mute connected client.
Which probably needs to be imported.
Okay, we are not importing it.
You should, you should be able to click and say fix it.
Yeah, let me try.
Quick fix.
Control dot. Split import.
Oh, did we make it private, not public?
Probably we forgot to make it public. Where is it? Yeah, no, it's public.
Okay, so let's just do
Let's just write.
comma connected client. Yeah, like ancient developers.
And here is complaining that it wants type mismatch. Okay. So the callback that we declared is a private message listener.
Which is an alias. Private message listener is an alias for a box din of a closure.
Yeah, so where is different from the one here? This is a vec box implement of a function, private message.
And then I think that's the important part, the one that is not shown.
It's not going to respond it.
If you hover on private message on the variable in line 14. Okay.
Okay, vector box function, private message, mutable connected client. And what do we want? Vector box din function is the din
Rather
difference.
than, yeah.
One is an impelm and the other one is din. Is that the difference?
Interesting. Okay. So can we just change the signature of our listener?
The one that we declare here.
Okay, this is already a din. And what were we getting there in the error? If you hover on private message line 23, it just says closure. Oh, it's the plus static. Is that it? What Tommaso is suggesting? So should we say in our closure definition in the not there
Here.
in the listener definition?
Here.
If you say after the parenthesis before the angular, yeah, do a plus tick static, and same the one below.
Okay, now what is Sega's?
No, still complain.
Complain about. Okay, just a second. We wrote this with this lifetime. Do we have to add a lifetime also here?
I
No.
don't know. Do we have a lifetime in connected client? No, right? In the definition of the struct itself.
No, in the definition of the struct itself, no. But here it wants mutable static for the connected client. So this one, should we add this static
We did.
here or here?
Yeah, I think the problem is that it's not getting our closure as a din somehow. Like if you look there again, regardless of static, are all the lifetime of private message and the mutable? Good question.
We have
Are
no
the lifetime of...
We don't have lifetime declared here at all.
Yeah, there is something weird, I think, with that closure. What if you remove din from the listener definition?
Okay, so you want me to keep this like this with the closure declared live? Because I was thinking of creating a function, but let's do that later. And
Oh, no, sorry. Can you go back to the run method?
Here?
What are we declaring there?
A vector of private messages listeners.
Okay, the thing that I'm confused about, if you see the type annotation there in line 14, it is a vec box, blah, blah, blah. So if you hover that on priv message.
This one?
Should show you the type. So implement function. When we say implement function, isn't it a din? I think so. And then there,
so if we go, Okay, I copy and pasted the type. And now he's complaining about something else.
Yeah,
Client.
because to do client run, their client needs to be mutable. So in line 22, you need to declare it as let mute.
Okay.
Ooh,
Now,
okay.
what is he complaining
Okay, we are creating a future that we are not using.
Unused implementer of future that must be used with a dot await. Dot await where? Because we have an await here. Or we need a dot await here.
Maybe. What if you
Because
do that? If you do dot away at
let
the
me see.
end?
Use unused implementer of future that must be used or poll. Unused result that must be used.
Yeah, the problem, as Thomas is saying, that we are not. We created a promise that nobody's polling, so by default, it's not even starting. So we need to start it somehow. So
Okay,
I
you
don't know
can do
if I
this.
don't know if we can do a wait there. Otherwise, we need to do an explicit spawn somehow, like on the Tokyo column spawn. I think. What is it
Tokyo,
called?
capital Tokyo.
No, that's correct. Let's see. Tokyo spawn future. I can never remember how to do this stuff. Yeah, should be Tokyo column spawn. Why that
Okay,
didn't
so
work
here,
for you?
colon, spawn.
Why it doesn't autocomplete?
I have to.
Oh, because we
Mm,
never no we have implicitly
Tokyo is
imported Tokyo. Yeah.
yeah, Tokyo is used here, so in theory it should have it. Or I have to import something
No,
else.
because you are using the full namespace. Okay. Now
Phone
inside
what?
there you can pass the async block inside of it. Is that gonna work? Why not? You don't poll the future. It is completely ignored. It's not JavaScript. Yes.
Borrowed data escapes outside of the closure. It's going around. It's going around. Because of the spawn, it's going outside.
Which borrow data does it tell you? M is a reference that is only valid in the closure body.
And we are
Okay, do we
passing
need
it
to do an
outside.
async move? What if you do async space move in line 18?
More
No,
magic, guys.
doesn't
More
like it.
magic.
Add more magic. Connected client cannot send outside the callback scope. You cannot move the connected client. Okay. So
What if we do just an async function here? Called callback because I lack a fantasy that is taking whatever it needs to take. Right? Taking this.
by the
And is an
way,
async functions, okay?
as you read
Inside
that,
the
I'm gonna say that my original idea was to put mutexes everywhere and call it a day.
sorry, we took another direction.
Yeah, I didn't
Are you
expect this change. Yeah,
are you upset?
no.
Don't kill me. Don't kill me. And yes, callback is also not written like this. And then can we have a vector with this guy inside? So I don't know why I didn't took this piece of the code. So now here, instead of this, can we do callback? Now, this will be a function callback private. The type is not matching again.
Because now
It's
is...
not a box anymore.
Wait, what is it though? If
It's a
you
vector of this.
go again on line 23, what does it tell you? Click for full diagnostic.
Yeah, the types between that vector and this are not matching anymore. Because this type is this thing, but like I did before, what is happening if I just hard code the
But
strange
now
type
you're not
here?
gonna know what a callback is.
Yeah.
And
Can we
callback
just
is gonna be user defined, so it's not something we can predict. It
No,
needs to be
it's
something
not
else.
something that we can predict. How can you try this?
Yeah, what I knew is that what fn is for. Because fn uppercase. So there is fn lowercase, which is an explicit function that you know in advance, and it's the type of that function only. I don't think you can do that
Okay.
because fn is a trait with the uppercase.
Okay. It's getting complicated. Do you want to
Yeah.
go with the mutex and go back to where
Let's
we
try
were?
one last thing that Tommaso was suggesting, which is to use this block on rather than the spawn. So go again to the closure, because I think the closure somehow gives you a type that is a bit more generic rather than just referencing an existing function.
Yeah, give me a second. I'm doing Control Z enough time. And we were before the Tokyo spawn. So you want to go back to
So rather than using spawn, I
here.
think Tommaso is suggesting to
And
use a block on.
and here it was complaining that this must be used or awaited. Right?
Yes.
Okay. How do you use a block on?
That's what I'm trying to figure out. There is a link here. Let's see if we can figure it out. Oh, but we need to create a new runtime explicitly.
What kind of sorcery is this?
Okay, I'm tempted to suggest we go back to the idea of mutexes.
Okay, so revert. I think the idea of splitting the client and the connected client is still good. Or not?
Oh, sorry, there is an ad going on.
Oh, I was not seeing that.
Okay, sorry for the ad.
So, switching back to the idea of the mutex, we still need. Do you still want to split the connected client and socket because it makes sense?
Yeah, I think so.
Okay, perfect. Then instead, here run is just taking run. So we are going back to not too much. We are going back to just take self. Correct. And here, oh, we need to go back a little bit more because we have to go back in time. I hope to have enough history. I Control Z. This was wait. Think that is fine to go up to where?
Yeah, something like that. Which we still didn't figure out how to make that async block work, but we'll get there.
Yeah. Then on run, we have to uncomment this because we are keeping the arrays inside the vectors, sorry, inside the client. So we have to revert this bunch of code. Okay, now here we loop, and here we have to loop on top of self client on a private message. Now it's complaining about not being able to borrow self as mutable. That is what we are trying to address with mutex.
So the idea of the mutex is that everything mutable is wrapped in a mutex, and that allows us to use interior mutability, which means that from the outside you don't know that you are mutating an object. So you just have a shared reference. From the inside, there is a mutex that is making sure that that mutation happens safely.
Okay. So we have to decorate with the type mutex a bunch of stuff. What are we mutating? The client needs to be inside a mutex because we loop on top of the vectors.
No.
Okay.
No, because when we loop, we're not going to change them, right?
No, but here is complaining that we can't move a private message which is behind a mutable reference. Then I don't know where is the mutable reference coming from.
Oh, that is coming from self. Self is mutable there. Right?
Yeah. But one possible solution was this one, but then it was complaining that we can't borrow self as mutable because it's also borrowed as immutable.
And we will remove that as soon as we change run into line 89 from ampersand mute self to just ampersand self.
Okay, so we have to do also this. Okay, but then the listener needs to take a mutable client or an immutable client. It should take an immutable mutex at this point.
An immutable
mutex connected client.
No, I think just a connected client will be fine. Inside, some of the properties of connected client will be wrapped in mutex.
Okay, so now here is inferring the type on its own.
Okay, so that looks good. Or now some of the methods will fail because they are telling us, well, how can you
cannot borrow socket as mutable because it's behind the reference to
exactly
immutable. Okay,
perfect. Now the socket needs to be inside a mutex.
The socket that is declared here needs to be inside a mutex at this point. So all of this type that is already long enough becomes even longer.
And now make sure to import the mutex from Tokyo, not the standard one. This one, yeah.
Okay. Where is it?
Okay.
Here.
Don't delete that import because we'll need it later.
Sorry. I will never delete it again. And here at this point, we have to lock before doing next because now it's a mutex.
Exactly. So when we create, here you need to do lock dot await, lock parenthesis, and then dot await dot next.
Await without parentheses.
Do we also need to unwrap? We might.
It's not.
I think that lock might fail.
No, this is a result.
Because there is a result. So you need to do lock dot await dot unwrap dot next.
Can we do let sum or is something
no
you don't do? Okay,
let's just do an unwrap for now and we can discuss
before the
later
next. So here,
yes, what that means.
I need a wider monitor, guys. It's getting longer.
Is it there? Oh, then it needs to be before the await. Is it?
So let's split this down in types. Sorry. If we arrive here, what
Yeah,
we
let's
have
just do it somewhere
up to
else.
here. Up to here, we have. Sorry, guys. Give me a moment. Let temporary variable look at this. Is a mutex guard. On top of the mutex guard, what do you have to call?
Oh no, then it's correct. You just do temp.next. Because we do the if let okay in line 96. So it needs to be a result. It's the next that can fail, not the lock.
Mm.
Okay, sorry, I got confused there. Too many types.
Yeah.
So this temp you can call it whatever. By the way, I am not sure that this is correct now. I think we need to do one liner because otherwise
One
this
liner.
temp is gonna
Okay.
live forever and we will have a deadlock.
Is living forever. Okay, now cool. We have our result. If let okay message, we do what we have to do here. We use socket also here. So now
We
every
need to do the
time,
same dance. Dot lock, dot
okay.
await.
So everywhere there is a lock, I have to add those two.
Mm-hmm.
So socket, lock await send. Socket, lock await send. Socket, lock await send.
There is another one at the bottom, I think.
Oh, sorry. Yes.
Okay.
Okay. And also here, lock await send. Why Rastan? Why? Sorry. Format document. Thank you. Oh God, all the annotations kill me. By the way, here you see that you have your future, your await, your send.
Okay. Now this
Somewhere.
sorry, that
This
send
should
message.
be mutex new.
Mm-hmm.
Yeah. Okay. The send message. What?
You can see now that every method where we receive a mutable self, I don't know why it's not complaining, but it should complain that it doesn't need to be mutable.
So here we can get the self.
Mm-hmm.
And everything should work. Okay.
Similar in the run, which we already did.
So yeah, I think we have just those two inside the implemented connected client. Okay. Now here, client borrow is mutable, not declared as mutable. Okay. We are back to the
This.
future must be awaited.
Okay.
We are back to here.
Mm.
Here is complaining that this is never used. Okay, fine. I know. Here the mutex are working. Here we have to use some mutex. No, because we use the mutex inside the send message, so we don't have to do anything here. Okay. Correct.
Correct. So again, we have the problem that we are creating a promise, that a future that if we don't poll explicitly, it's not gonna start.
Yeah, our problem is that this one async.
Exactly. So it retards the future immediately. So this is basically, imagine like if it's stopping at the beginning of line 79. Right? As
Yeah,
long as somebody doesn't poll it, it doesn't even
this doesn't execute.
doesn't do
Yes.
anything. Yeah.
So we have to await it because it's an async function. And
But
it's an async function because this is an async client. So it should be async. At that point, we need to await it. And to do that, we did that inside an async block here.
yeah, the problem
But
is that the
then
async block on its own
it's
needs to
never
be
awaited.
exactly, which I don't know how to await. And I
And we
thought
can't
you can
move
just
it
do a
out.
Tokyo spawn.
And but if you do Tokyo spawn, then M is moving from the closure to the spawned Tokyo coroutine closure, and is going outside of the closure, and it can't. How do you declare an async closure? Can you declare an async
I
closure?
don't think so.
You don't think so?
Rust
So how do you call
async
an async
closure.
function from a closure? At this point, the question becomes, how do you
Exact.
call an async function from a Rust closure?
It's a ChatGPT question.
Yay, ChatGPT, solve it for us. We are done. Enough. I mean, if you were asking me 1 year ago, are you going to speak about this kind of stuff about function mutex and so on in a stream? I would have said, no, never. I don't
Are you
understand
crazy?
them.
Yeah.
I will never understand them. And now I think we are talking about them quite comfortable.
But I don't know if we still understand them properly.
I talk for myself. I don't grasp it completely. I have a little bit of grasp of what is happening here, and but we can ask the right questions. I mean, asking ourselves,
Okay,
how do you
let's
call
do
an
this
async?
scrappy thing, which I don't like. I'll send you somewhere.
Can't you just tell me?
It's very long.
Oh God, perfect.
But it's again using the block on that Tommaso was suggesting. So the problem is that we need to create at the top before outside this disclosure. Let's create a runtime.
How do we pass the variable to the runtime?
So I don't know. We'll get there. Runtime equal runtime uppercase. Yeah, that's the one. Runtime new. You need to do a dot unwrap or the question mark. Yeah. Tokyo runtime new. Okay, now that we have a runtime, you can do runtime dot block on and wrap the entire async block.
I don't know which shortcut I did, but I was able to close the block.
Okay, runtime does not live long enough. Beautiful. So I think that again we have a problem with.
We have to create it here or there.
Yeah, what if you do it there? Let's see.
Boom. Now,
Result must be used. Okay, that's just a warning because that might fail and we are pretending it can never fail. This should compile anyway. It's just that in theory we should do some kind of if statement, like if
do
it
you want to
fails, we
try
don't.
if this is going to compile?
Yes.
You still see my screen?
Yes. Just use handle current. Ooh, what is it? Handle current. Okay, let's send messages.
Boom.
Exploded.
Exploded.
I've
So
tended to
these
block
are
the current thread while the thread is being used to drive asynchronous tasks. Cool. This is where we are very ignorant with Rust async.
so before you were suggesting of doing a spawn, right? But then
But
it's complaining
just Tokyo spawn.
that is
Tokyo
complaining.
column.
Yeah, but Code Whisper was suggesting to do runtime spawn.
So
Then
Tommaso
if
is
you can
suggesting to
notice,
say handle current. But how do you use it? I have no idea. I'm trying to figure out. If you have any documentation link, please share. Okay, there it is. Just use this. So uppercase handle colon current block on.
yeah, if it remove all the suggestion that is trying to do, it can write very what it was on block. Sorry, block
So
on,
now
not on
delete
block.
runtime as well.
Yeah.
And it's uppercase H and handle, yeah, and then current parenthesis block on. And
I
now
have to import.
handle probably import that one, yes.
There is only this one. Okay.
And now I think
We
you can
don't
remove the
need
runtime.
the runtime anymore. And now it's complaining that.
The same, we are not using the
Okay.
result, yeah.
Okay. 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 Cool. Okay. Running. The first one that send a message, and we error out again. So the message was printed, and you sent.
An emoji.
Yeah, this is
Yeah.
an emoji. Yeah. And it errored with attempted to block the current thread while the thread is being used to drive asynchronous tasks.
Okay, I think this is a good point to stop. But if we have to do
Yeah,
a summary,
I
we
think
need
we can stop with this error. I mean, it's compiling, it's crashing. Yay. Why? Because we have to call an asynchronous function from inside a
callback.
a callback. Yeah, and if we declare an asynchronous callback like we tried to do before, like async def callback, then we have problems with the types. We have not def fn, sorry, def is Python. Yeah. If we define the callback like this, we need to be able to specify to change the types to take any kind of callback. At that point, that will be just add private message listeners this callback. So it will be easier because all the
Yeah.
asynchronous stuff will be fine. But then we have to fight with the types of this callback. That can be the other approach. We don't use closures, we use real declared functions that are already declared as synchronous. So you don't have to do this async block inside them, right?
I don't know if that would work. I'll need to think about that. I think there are other things that we'll need to think about. One is that maybe Tokyo offers a way to do this that it's not gonna crash. So to handle this, like you put it in IQ or something like that, rather than trying to block immediately.
Yeah. What we have here? We have spawn, but I think we have block on, spawn blocking.
Try spawn. What is spawn gonna do?
Complaining that
Future cannot be sent between threads safely. The thread sync is not implemented for.
our
Oh,
function.
because the socket probably cannot be.
No, it's our function that doesn't have the sync trait.
But the sync trait, I think, should be automatic if everything in the scope is sync, which I think is not going to be sync because of the socket.
Required by this bound in end of spawn, and the future send static.
So okay, that's one thing we need to think about. If Tokyo can give us some tool that we are not using. The other thing is maybe this callback based interface is not ideal. Maybe there is another way which is better. And the other thing is that we are syncing, where we are mixing a sync context with an async context. And if we start to bring this library into Bevy,
Yeah,
we're not gonna
then
have
we have
async.
even more asynchronous stuff happening.
So yeah, maybe we'll need to do a little bit of research to see how people use WebSockets in Bevy, and maybe there is another interface that we can come up with.
Yeah, I think that we can stop it here. We made some progress. We tried an approach. We fall back. We tried another approach. And we are back where we were, but through two different rules. I think this one is better, to be honest, after having tried both of them.
Mm-hmm.
And let's see.
Why not allow async callbacks? I don't even know if they exist as a thing. So if they exist, that's another thing to research, and it could be a good
But I
solution.
mean, allow async callbacks. If disclosure was async, yes, it was. Yeah, instead of a function and async function. But then we have to find a way to declare the async callback. Callback return a future.
So it's just a regular function that returns a future. Yeah, that could be another way. Then I think we still need to figure out.
Return a future. So the closure can return a future, and then we await that one. What we do inside our client in the run? In the run, we call it. So if we could just do an await here, at this point, the listener should return this. So I just need to remove the semicolon and everything at the end of this. So now we are we returning this? Expected unit type. No, we have to change the type.
No, sorry, because you're doing a let there inside. So, well, I guess that doesn't matter too much. It's like you are.
No, it's here that we have to declare that the function returns. So this function return a future
Of good luck because
of let's say nothing.
Okay, fair enough.
But future needs to be imported.
Yes, from
This one.
I thought it was in the core.
I thought it was in Tokyo, but
Okay, now it needs to be a din future because future is a trait.
So like this. No.
And now zero generic arguments. Yeah, I don't think that type is correct. Remove the import, the future import from future utils. Yeah. Does it suggest you something else now?
Future utils is the only suggestion. Because at that point, the close at this point, this is not comment also this one. Closure could return the future, but we have to declare that it should return the future. So can I be explicit here like this? But here is cannot find a trait in this scope. Future utils standard future. This one you wanted to use this one?
That's the one I was thinking about.
Okay, let's add it manually.
I don't know why it doesn't suggest it to you.
Okay, now it wants the output type.
Okay, that makes more sense.
That was what we wrote before. Now it's complaining about trait.
It needs to be output equal parenthesis because it's an associated type. Okay.
And
Oh
this one is complaining that box the new return type and wrap all returned box new.
Okay, so you need to return box new of async, all of that stuff.
Box new. Okay. Now what is complaining about now? I did it. No? He's not happy about what I did.
Return cannot have an unboxed trait. You just did that, right?
That is thinking what is telling me the console. Okay, it's telling me the same. Now it's complaining in the loop because it's a box. It's returning a box. Can we await on top of the box containing this trait object return an unsized value? Dynamic future util. The dynamic is still needed.
So it's the listener. Yeah, I think the dynamic is needed because future is a trait and not an actual type.
My VS Code is.
I will say let's call it here.
Yeah, okay, let's stop it here. But I got the general idea. The callback is returning a future, and then we await on the future that the callbacks return. I think we are a little bit nearer to the solution, so we don't have to manually work with handle runtimes or whatever.
Yes,
Right.
even though I'm not really sure I like this interface, but we can discuss that next time. Meanwhile, maybe we can think a little bit more about what an ideal shape will look like.
Cool. Let's close it here then. Sorry.
Okay.
I got dragged away by coding.
Okay, so thank you very much to everyone following along today. And I hope it was fun, even though you probably saw us swearing against Rust most of the time and not doing much progress. But
I had fun.
Maybe we learn stuff, yeah. So thank you also to everyone in the chat, especially Tommaso for all the suggestions. And I think the only thing I'm gonna mention is our usual YouTube channel. If you want to see the previous recording, we are gonna be posting the recording of today as well there. So I guess
after removing all the swear words, yes.
After removing all the swear words, and I think that brings us to the end of the stream. So thank you very much, everyone, and we'll see you next time.